Hello, welcome to Solving Systems Using Elimination. In part one, we're going to look at strictly using addition, and I'm going to add subtraction because you can actually subtract too. So let's look here at what they mean. It says solve the following system of equations, and we know that we know from solving systems that we need an ordered pair, so we need to get one of the variables by themselves. So the goal is to cancel one of the variables. Once I've canceled a variable, I can then solve for the next one. So here what I'm going to do is, since I have opposite variables right here and they're the exact opposites, I'm going to add this equation. I'm going to add these two equations together so that I can cancel them. So I'm going to cancel the y's. So I'm going to add. I have negative 5 plus 10, negative 5x plus 10x. Well, negative 5 plus 10 is 5x. 2y plus negative 2y, that's 0, so those go away. So there's nothing here. And then my equal sign. 4 plus negative 14 is negative 10. So now that I've added them all together, I can divide by 5x, or divide x by 5x by 5, excuse me. And so x is going to be equal to negative 2. Next, what I want to do is take that negative 2 and plug it in for x somewhere, wherever it seems easiest. So I'm going to go back up to negative 5x and plug it back in. So I have negative 5 times negative 2 plus 2y equals 4. Negative 5 times negative 2 is 10 plus 2y equals 4. I'm going to subtract 10 from both sides. And I get 2y equals negative 8, y equals negative 4. So my solution is negative 2, negative 4. Alright, let's look at a couple more examples real quick. In this first equation here, which we'll label B, and we'll label this one C, so we can remember them apart, keep them apart. Says solve the following system of equations. And so I want to think about using elimination if there's two simple ways. So in the previous problem, I had exact opposites, but here I have exact numbers to eliminate, but they're not opposite. Well, if they're not opposite, then you can subtract. So if they're the same signs, you can subtract. And we can even make that note, same sign, subtract. And by that I mean these. The same signs were addition. So I'm going to subtract the whole equation from each other. So 3 minus 6 is negative 3. 4 minus 4 is 0, so those go away. 8 minus 20 is negative 12. Now I can divide both sides by negative 3. And x equals 4. Now that I have x, I'm going to plug it back in to one of the equations. Just go to the top one, the top equation. So I'm going to have 3 times 4 plus 4y equals 8. 12 plus 4y equals 8. Subtract 12. 4y equals negative 4. Y equals negative 1. So my solution for negative 1. Let's look at this problem real quick. I'm not going to solve it all the way down. We're just going to look at how to start it. Now, it's kind of tricky because I have x minus and then x plus, but really, these are the ones I want to cancel, and their signs are the same. They're both positive. So that means I subtract. So I do x minus x, which cancels these. Negative 2. Oh, hang on, let's put the subtraction out. X minus x, those cancel. Negative 2 minus 5 is negative 7y. 9 minus negative 12 equals negative 21. Excuse me, positive 21, because it turns to 9 minus negative turns to plus plus. So it's positive 21. And y is negative 3. I'm going to substitute that back in. So let's go to x minus 2y. So we'll x minus 2 times negative 3 equals 9. You have x minus negative 6 equals 9. That's x plus 6 equals 9. X equals 3. So my solution, negative 3, 3, negative 3. Alright, so just remember, if they're the same sign, subtract. If they're different signs, add. Good luck.